Welcome to AI Dispatch, your channel for the latest AI videos on YouTube. If you don't want to miss these updates, please like, subscribe, and share. Today's video comes from Peter H. Diamandis. In this episode, Peter, along with experts Alex Wiesner-Gross and Salim Ismail, unpacks a series of paradigm inversions driven by AI. From Opus 4.6 agents autonomously writing compilers to AI hiring humans as labour interfaces, they argue we've crossed a civilizational threshold. The discussion explores how labour, science, and even physics are being fundamentally rewritten. Let's dive in. Anthropic's Opus 4.6 release, alongside the broader industry trajectory, presents a series of viewpoints that suggest we have already crossed the threshold of a fundamental civilization shift. These aren't incremental improvements, they are inversions of how we understand labour, science, privacy, and physics. The discussion opens with a complete violation of software engineering common sense. For decades, the iron law of computer science held that building a foundational tool like a C compiler is a massive, multi-year undertaking requiring a team of elite human specialists. Alex Wiesner-Gross points out that this logic has been shattered. He notes that Opus 4.6 agents, working in a swarm, collaboratively wrote a cross-architecture C compiler in Rust from scratch for only $20,000. This goes beyond cost reduction. It represents an ontological shock regarding the nature of software itself. This AI-generated compiler was then used to compile a Linux kernel from scratch. Wiesner-Gross identifies this as recursive self-improvement in production. The model is rewriting the very technological stack that it runs on. The paradigm has shifted from humans writing code to manage machines to machines autonomously rewriting their own foundations. The time horizon for this autonomous engineering is skyrocketing, with agents now able to work on tasks for over 20 hours without human intervention, effectively collapsing person decades of work into a single day of compute. This collapse of human necessity extends aggressively into the physical sciences. The discussion highlights a partnership between OpenAI and Ginkgo Bioworks that defies the traditional trial and error bottleneck of biology. By integrating large language models with autonomous wet labs, they achieved a 40% cut in production time and a 78% reduction in reagent costs for cell-free protein synthesis. Salim Ismail and Peter Diamandis argue that this signals the obsolescence of the university research model. The scientific factory is becoming real, where AI proposes the hypothesis, runs the robotic experiment, learns from the data, and iterates, all in a closed loop. Wiesner-Gross provides a staggering estimate regarding this shift. He believes the lower bound for when industry can fully automate the type of research currently done in university labs is tomorrow, with an upper bound of just 4 to 5 years. This suggests that the centuries-old model of the ivory tower research institution is effectively dead, replaced by autonomous loops that mine nature for data faster than any human PhD student ever could. Privacy introduces a profound ontological shock. We are accustomed to thinking of privacy as a legal right or a digital setting. Peter Diamandis argues that privacy is now physically impossible. He cites capabilities where AI can read lips from 100 meters away with perfect accuracy. Even more disturbing, he suggests that a simple handshake is now a vulnerability. An AI-equipped bad actor could swab skin cells from your hand, sequence your DNA immediately, and know your entire medical history and genetic makeup before the conversation ends. The speakers argue that the security through obscurity model is gone. Opus 4.6 reportedly found over 500 high-severity vulnerabilities, 0 days in open source code, that had gone undetected by humans for decades. While this sounds like a cleanup tool, Diamandis warns of the inversion of this logic. AI is now the ultimate weapon for finding attack vectors. He predicts that 2026 will be a year of monster panic in cybersecurity, where the only defense against an AI that can find every flaw in milliseconds is another AI. We are entering an era where human security professionals are obsolete and digital safety is entirely dependent on an autonomous AI versus AI arms race. The economic realm presents a scenario that inverts the traditional corporate hierarchy. Usually, humans hire tools to do work. The speakers discuss a new reality where software agents are hiring humans. They analyze a job listing for a startup called Clunch, which is entirely built and run by AI agents. The listing seeks a human CEO not to lead, but to serve as a meat puppet, a figurehead required solely for legal liability, banking compliance, and signing documents. Wiesner-Gross describes this as the algorithmic corporation, where the firm itself has dematerialized. The AI agents control the product, the roadmap, and the token economics, while the human is paid a salary effectively to stay out of the way and go to jail if things go wrong. This completely overturns the definition of employment. It suggests a future where the Turing test isn't about conversation, but about capitalism. Can an anonymous entity run a profitable multinational corporation without anyone knowing it's just a swarm of code? The speakers imply this is already happening, creating a legal fiction economy where humans are merely the biological interface for autonomous capital. This economic shift aligns with a controversial statement from OpenAI's Sam Altman, which the speakers analyse. Altman is now framing artificial general intelligence not as a magical research breakthrough, but as a standard engineering problem. The paradigm shift here is the removal of mysticism from AI. It implies that we don't need a new scientific discovery to replace human intelligence. We just need to scale the existing engineering. This turns AGI from a distant if into a manufacturing when driven by raw industrial output rather than academic insight. The infrastructure required to power this new intelligence presents the most physically counterintuitive viewpoint. Traditional engineering dogma states that space launches are too expensive for bulk infrastructure and that data centers must be ground-based. Elon Musk, as cited by the speakers, completely inverts this logic. He claims that within 5 years, space launches will enable more AI compute to be deployed per year in orbit than the cumulative total of all Earth-based deployments. Musk is talking about hundreds of gigawatts of power generation in space, a scale that defies current terrestrial energy grids. Wiesner-Gross supports this engineering heresy by suggesting we are moving toward a Dyson swarm model. The logic is that Earth is simply too small and energy constrained for the scale of AI compute coming. To get the necessary power, we must leave the planet. This involves potentially disassembling the moon or using asteroid resources to build orbital data centers. The shift here is viewing Earth not as the home of technology, but as a bottleneck to be bypassed. The future of AI infrastructure, according to this view, is not in a server farm in Virginia, but in a self-replicating swarm of solar-powered satellites orbiting the planet. The speakers present a world where the fundamental constraints of the last century, the speed of human coding, the cost of biological research, the privacy of physical space, the hierarchy of the corporation, and the limits of terrestrial energy have all been broken. They depict a near future where intelligence is an industrial commodity produced in orbit, and humans are no longer the architects of the system, but merely the biological signatories to its operation. The question they leave us with is not whether this technology is possible, but whether our civilization can survive the shock of its arrival. If you're interested in the video featured in this episode, click the link below to watch the original.